Okay, so back when we were originally talking about series, we actually made a kind of subtle change to what we mean by equality, what we mean by two things equaling each other. So if we had an example, or if we had a series that looked like 1/2 plus 1/4 plus 1/8, this is the 1 over 2 to the n series. Um, and you may remember that we said that if we take subsequent partial sums of what this series is, as in if we add up the first two and then the first three, first four, etc., we'll see that this limits toward those sums limit towards adding up to one. And then so we actually said that, hey, this infinite list of numbers, an infinite sum, or the sum of an infinite list of numbers actually equals one. And when we said that, we were kind of subtly expanding what our definition of equaling one is. If you go on to take more math classes, you'll see that dealing with infinity can be really, really tricky, and you can get all kinds of weird stuff happening if you aren't careful with what you say things like equality means. That said, this is a situation where it's okay to say that this thing equals the thing that it converges to. It gets a little bit cumbersome to always say, oh, this series converges to one, and just say, oh no, it equals one. Okay, so we're going to do the same type of thing with these Taylor polynomials and Taylor series. So up until now, we've been saying, hey, we can come up with a pretty good approximation of a function f of x by looking at, let's say, a second degree polynomial, or a third degree, or an nth degree polynomial. And those are all pretty good approximations. They get better and better as you add more terms. All right, so this shouldn't really be a shocker, but the idea is, if rather than adding just a finite number of terms together, if we let this go infinitely far out, then we're actually going to say that this sum of a whole bunch of polynomials equals the function in question. So for example, you may recognize this Taylor polynomial, 1 plus x over 2 plus x cubed over 3 factorial, etc. This thing, or these first four terms, this third degree Taylor polynomial, is a really good approximation of e to the x. And as we let these the degree get bigger and bigger and bigger, it's a better and better approximation of e to the x. So what we're going to say, and this is a generalization of our definition, we're going to say that this equals e to the x. All right, and that might not sound like a big deal, but we're slightly changing our normal mathematical definition of equality to include this infinite sum idea.